their valuable experience. Okay, so the style for this section is each panelist will give a quick presentation about their research, and then we'll follow by Q&A sections. Okay, so next, let's welcome our first speaker, Ben from Georgia Tech.
Well, I'm glad to be here, and during the next 10 minutes what I will do is talk about Internet of Things, but from the perspective of my own research since the last 10 years. On the physical Internet, I'm going to take about half my presentation time on stating what this is all about, so that you've got in your mind see the perspective that I've got, and then I'm going to move into Internet of Things and answer the questions about opportunities, challenge, and applications. I could have talked about healthcare and other topics like this, but I'm going to focus on supply chain logistics and transportation. Basically, we all know about the digital Internet. Today, our session is on the Internet of Things. So, digital Internet, we have bytes, okay, data packets of information that are moving through processors around the web. Internet of Things, we're connecting the billions of objects that exist in the world between themselves through the Internet and with us in organization for decision making. In the physical Internet, we're going to not be moving the bytes, we're going to be moving the atoms. We're going to be moving the objects themselves, the chairs, the boxes, etc. We're going to talk about this. And also, we've got the energy Internet, which is smart grid and so on. So this is the beginning of an era that we see we call the hyper-connected era. So that, and my focus will be on the physical Internet and the relationship with the Internet of Things. So basically, in the physical Internet, we're trying to make the way that we move, we deploy, we realize, make products, that we supply them, design them, and use them much more efficient and sustainable across the world, because we claim that right now we are facing a wall related to this. So economic, environmental, and social perspective are what we're tackling at the worldwide level. So for that, we've created what's called the physical Internet, which is an hyper-connected global logistics system enabling seamless open asset sharing and flow consolidation through standardized encapsulation interfaces and protocols. When we say hyper-connected, it's because we're interconnected on multiple layers, ultimately anytime, anywhere, and this interconnectivity is digital, physical, operational, business, legal, and interpersonal. When we say digital interconnectivity, the Internet of Things will be a big helper in making this happen. So we've got a series of enablers, okay, for the physical Internet. I'm not going to go through all of them. This is beyond the scope of here. Okay, so but I'm going to try to snap you a few examples so that in line with Internet of Things is going to help you understand our position. So first, okay, we're going to work to have standardized protocols that will provide this seamless interfacing. So going through a cross-dock, going to a DC, etc., will in a multimodal world, okay, is going to be much more rigorous protocol-wise, like we have in the Internet with TCP/IP type of protocols. We'll have the same on the logistics side with the open logistic interconnection model that I'm showing here. The same way the digital Internet is encapsulating all the data into data packets, and these are what is moving out across the web, and not your email by itself. Okay, the same way here we will be encapsulating the goods. The same way we do with the big shipping containers, we will be doing for all kinds of goods, all the way to tiny boxes. So we have transport containers, handling containers, and packaging containers that are going to be easy to store, and they'll design for logistics, basically smart and connected and eco-friendly. That's going to have to be a big impact on us, because this is what's going to be moving on the physical Internet. So when we're trying to talk about Internet of Things, that is going to be our primary source of connection. We're working on the new era of logistics facilities that are going to enable these seamless intermodal interconnection. So taking advantage of the modular containers I mentioned here, be they ports, cross docks, roadways, rail and road, etc. So there are many that we're working on right now. So we're trying to rethink the way, for example, this is showing consumer packaged goods flow all across France right now, using the two top retailers and their top 100 suppliers. So you see everybody's doing their stuff solo. This is real data. And here what we said is, no, we're going to use hubs, open hubs all across the territory. And like I showed a few seconds ago, and the flow will be from the beginning to an hub to another hub and so on, and across from territory, from source eventually to destination, with open consolidation at each open hub. Okay, so that's showing this and using the same highways and rail system. So we get very significant reduction in cost and greenhouse gas emission when we do such things. The same when I talk about transportation, let's talk about distribution. Right now, most companies, they have their distribution network, they have their own distribution centers or warehouses. Warehouses are used by a single company, just a few, or you deal with a third party and then it's going to place your stock on a facility by itself. That's what we see most of the places. Here what we see is, what if, when we begin to deploy only modular containers, so for example, in the US, we have over 500,000 distribution centers and warehouses. So what we want is do like cloud storage and enable every company in the world to be able to deploy their product in any of those 500,000 through in the US, but through also all across the world. Yeah. Like in Europe, they're thinking about their trade corridor and flow and logistics corridors. They talk about infrastructure and so on. You've heard what I've said earlier. We are working now on thinking about the gateways and all the crossing points and how it's going to be played, the protocols to make this enable. Europe has made the physical internet their strategic vision for logistics and supply chain for 2030 and 50. So basically, the same we apply at the city logistics, urban last mile delivery level. So that gives you a lot of the feeling about what we're after. Now, if I go to exploiting Internet of Things, basically what we want to do is track every single modular container that we're going to have, anytime, anywhere, through the physical internet. And each of them is thought as a smart, active object. And so they are going to be equipped with Internet of Things technology. So monitoring, tracking, communication, and autonomous decision making. Also, all this when you're a manufacturer, a retailer, e-commerce players, or you're a logistic provider, etc. So you're going to play with a lot of assets that are not yours, that you're going to use as services. So we're going to have a lot of those control towers, cockpits, so that are going to be exploiting all the analytics and optimization and control fed by data that's going to come from a bunch of places, but notably through all the sensors that we're going to exploit in Internet of Things. Okay? So let me focus the last few minutes that I have on the opportunities, challenges, and where we see the most of the applications. So basically, like I mentioned, we want to have like those billions of boxes, packages, and containers that are moving all across the world. We want to be able to track them anytime, anywhere within the system. That's a lot of big data fed all across. At the same time, subject to confidentiality protection. So what is in the container or the box, is going to be known only by the seller, the client, or the users, and the officials that have control and to make sure that we don't have bombs and drugs or whatever in there. So that's very important. The hyper-connected competitive, so competition at the same time as collaboration, created by the physical internet, rewards very much smart, fact-based, holistic, live decision-making. And that will be a big opportunity for Internet of Things. How we can use Internet of Things to permit this decision-making that's going to get based on multiple information fed all the time. And the fact that we've got world standard containerization protocols, interfaces, facilities, etc., will enable the efficient wide market development of analytics capabilities, because you're going to be able to repeat it in many places, use them in many places, instead of having to do all the time customized development for each one. So that is very important. You're a user, service provider, government's purposes, and so on. So you're going to be able to use them all around due to this much more protocolized type of world, and using them operational, tactic, and strategic needs. The challenges, okay, well, basically, we're going to have multi-user, multi-source, geographically dispersed big data to be gathered, fused, filtered, validated, etc. Okay, and we're talking billions, okay, of them all across the world. Yet, this said, this is much less than what they're targeting right now globally for Internet of Things, because they want the table, the chairs, the doors, everything to be Internet of Things connected. So at least here, we're offering a very controlled type of terrain to experiments. Making it making it possible for decision makers to exploit the time and visibility advantage procured by IoT-enabled analytics. It's the time-wise, it's a question of how many minutes, of seconds, minutes, or hours am I gaining by having the Internet of Things capability, and how good am I to exploit it? If I don't exploit that time advantage, then you're losing money all across. And the same with visibility. How do I exploit the fact that I see much more than earlier to take better decisions? That's going to be a huge challenge to make this happen. Feeding, facilitating multi-facet, multi-criteria, collaborative decision-making, okay, like I've shown with those control towers. Okay, how do we make all this information captured and taking, for example, economical, environment, and social consideration at the same time? Important to go from beyond descriptive analytics, which is going to be the basic, to go to predictive analytics to make sure that based on that information we've got live, okay, that we can project a few hours, a few days ahead to help decide more or on a longer horizon. I put it as a simple sentence, but making exploiting analytics easy, intuitive, insightful, and powerful. If this is going to fly, it has to be working for the people who want the logistics supply chain, make them happening in the hyper-connected way. And also what will happen is, instead of more and more, the challenge is that instead of thinking of an analytics package on the side, it's much more like having an advisor, an analytics agent, okay, that will provide insights, okay, on an ongoing basis with the decision makers in the domain. Applications, basically, at the end, ultimately, every supply chain logistic decision maker in all levels of companies, okay, should be seamlessly leveraging IoT-enabled analytics. Early application will focus on alerts, patterns, clusters, insights. That's where they're going to be the first big shots, okay, in there. And typical applications starting and then growing, detecting anomalies, risk, opportunities for transportation, delivery, distribution, production, supply. Making sense of a portfolio of key performance indicators. We've got 20 to 30 performance indicators that are fed by IoT. But how do you make sense of this, and how this gives you insight to get more decision and do deep diving into the causes and the actors that are associated in making what we saw as a red light, for example, happening. Supporting focused investigation, for example, what's the resilience of our supply chain, or how do we get more service capabilities into our supply chain? So the analytics will help figure this out. And basically, another level that's very important is enabling to discover and to assess business opportunities in this new overall field. So I tried to do it in a reasonable time to give you an overall view from our physical internet perspective on IoT analytics. Thank you. I'll be glad to answer any questions later on through the panel. All right, so I'm going to
just give you sort of a high-level overview of IoT and my perspective rather than focusing on several projects of mine. So just the very last two slides are briefly going to touch on two projects. So first of all, where do I see the money when it comes to IoT, right? And this is completely my perspective, so feel free to dispute it later during the actual discussion, right? So there are two sides of the coin, sort of B2C and B2B, right? So in B2C, sort of, you are all familiar with sort of all the data that comes out of our smartphones, and then you have the Apple Watch, the Fitbit, the Jawbone, etc., right? So how many steps did you make in a day? So you can get that from your phone. You can get sort of all sorts of health information. So Apple has now what's called health. I don't use it that often. It's a health something app, right? And then you have sort of fun facts, and I put fun facts there because I know that Joe Bone, for example, released, I don't know, 6 months ago, sort of data about when do people go to bed and wake up, sort of in various big towns in the U.S. Right? So, yeah, nice. So, I believe that there is money in B2C, but it's not going to be the prevailing portion of the market, right? So these companies here, they'll make money out of this, but I think outside of those handful of companies, I think I don't see sort of a big market, right? And here, sort of, and I'm, even though I'm not listing here, I mean also stuff like connected fridge or smart fridge, say Nest thermostat, etc., right? So yeah, there will be market, but I don't think it's going to be that big. So I think the real money is actually in the B2B space. And we heard sort of both of the previous speakers actually talking more about the B2B aspect, so about the industrial internet that was proposed by GE, and GE now has a huge lab in the Bay Area, sort of all around sensors coming from machines. So not from our consumer devices, but from machines. So Caterpillar, for example, now has sensors on their bulldozers and other sort of heavy equipment. Schneider in Schneider Logistics, they have sensors on the truck engines, etc. Right? So you have truck engines, heavy machinery, aircraft, medical devices, sort of, and there's tremendous opportunity out there for B2B, and I think that's where the market, if you look at it in terms of the dollar, that's where that's where I think the big portion of the market is actually going to be, just because you have all these big players that are already sort of stepping into this space, and there's a lot of opportunities in this market. All right, so let me now just briefly touch, so transitioning kind of on a few of my projects, briefly touching on the IT stack behind Coda, say a typical IoT implementation. So you have sensor data coming in, right? So it doesn't necessarily have to be Node.js on the web server side, okay? But let's say you just have a sort of web server and a typical sort of modern, say, open source implementation would then pipe the data into Kafka. So Kafka is a distributed messaging system. And then from Kafka, so if you want to do real-time analysis, sort of one option is Spark streaming. All right, so that's where sort of the decision makers will be able to have a view of the data sort of in real time, as well as sort of any kind of predictive or statistical control sort of flags be raised in real time. So at the same time, so Kafka can pipe into Spark, or it's the other way around. So Spark streaming sort of can, for example, fetch data from Kafka. You can also employ sort of the ETL portion of Kafka, sort of a different Spark streaming job that takes the data and then sort of does the ETL sort of cleansing of the data, etc. Potentially stores the data in Cassandra for whatever later analysis that will have to be done on the data. And then once you have the data stored sort of in a database, and Cassandra sort of like, we picked Cassandra because it performs very well for time series data, and IoT data, so it's mostly time series data. Once you have it in Cassandra, so then you can use R or Spark or whatever you want to do the actual analysis, right? So this is where, for example, predictive analytics falls into, right? So this is where data science or more advanced analytics falls into, because when you stream and analyze in real time, you don't really have a lot of flexibility when it comes to analyzing the actual data. All right, so this is a sort of common stack that's behind open source IoT type implementation. Right? And it's not just a stack that we use, many other companies are also using the same IT stack behind IoT type projects. So let me briefly touch upon two projects now that I dealt with or that I was involved with. So the first one is actually through my company, the second one is research through Northwestern. And this is a manufacturing project where we're a pretty big, not huge, okay, but a relatively big manufacturer in Midwest actually didn't use any sensors on their manufacturing floor whatsoever, right? So clearly that's not the case for the GMs of the world, etc., because those are pretty sophisticated, so they have PLCs and they extract data from PLCs, etc. So this particular manufacturer didn't even have any PLC, etc. So we actually went on the manufacturing floor, we installed sensors, and then we started streaming the data coming out of sensors to our system, and we started with a very basic implementation, based on the stack that I have just presented. And that implementation will essentially count the parts that are being produced, and if the throughput rate significantly deteriorates or goes to zero, which means the machine is actually down, simply raise the flag to the repair folks there to actually to make them aware. Right? So this is no analytics; it's just plain reporting in real time. And then clearly the phase two, which we haven't yet kicked it off, is about then overlaying that with predictive maintenance application when it comes to answering the question of the type, when is the machine going to likely to go down, when should we repair a machine, etc., right? And I'm listing here fuel consumption as another application, so this is not really related to our particular application, okay? Another application that in different projects, for example, we undertook similar steps. So we started with something basic, all right? So and then in that particular project, we're talking about locomotives. So it was the data science slash advanced analytics part was how do you predict fuel consumption of a locomotive, for example, on a given track portion of a track. Right, this is one project. The second project was done with our School of Medicine, and the data here was a little bit more traditional in the sense it was all the data from a smartphone, and it was about depression patients. Right? So when they're released from a doctor's office or hospital for that matter, they give them a smartphone with their particular app, and the app essentially just emits all sorts of data to the database. In this case, it was actually MongoDB. Right? So the data is standard GPS type data, gyroscope data, but also SMS, not messages, but SMS activity, right? So when was a text sent out, when was a text received, when did the user start a Facebook application, for example. So all sorts of those kind of information was actually streamed back to the database. And this was the app worked only on Android phones. So our part of the project was essentially to analyze historical sleeping data, and now clearly we approximated sleeping with a variety of data from sensors, right? So we assume that, for example, if the phone stands still, so if in other words, if it doesn't move, say, for a certain period of time, that means that most likely it's sleeping, and it is during the same time, if there were no SMS messages, etc., we assume that that meant sleeping. So we focused on sleeping based on social activities, calls, and SMS messages. So essentially, historically, we created patterns, right? So it was kind of pattern recognition algorithm. And then in real time then, we raised alerts when that when the actual patient sort of deviate from historical sleeping patterns, right? So the second part was essentially anomaly detection, right? So it was sort of a mixture of anomaly detection based on clustering as well as sort of some simple statistics, confidence intervals sort of around basic statistics, right? So that was another project that sort of involved IoT, and it was, so from the machine learning perspective, there was nothing really striking, right? So, but just the concept of it was kind of interesting, right? So to sort of figuring out when a patient doesn't follow or sort of goes, quote, out of whack, and in that case, you know, an alert is raised to the actual physician, and physicians then can be proactive instead of being reactive. Right, so that's my 10 minutes, or hopefully even less than 10 minutes.
So, our last speaker is Professor Kumara.
Good afternoon, everybody. And, I think we had three distinguished speakers here, and it is nice to be on the same panel as one of your teachers. Though Professor Montreuil did not teach me, he was a professor when I was a student at Berkeley, so I'm honored. And my talk is a little bit logical, following everybody's, and especially when you're talking of sensors, my initial work was in sensing. Our first paper was in 1989 with the ASME, one of the ASME conferences, in which we were looking into the mission tool monitoring, and then we were looking at how the toolware is progressing. We looked into acoustic emission, vibration, and force sensors, and trying to represent those sensor signals, find the patterns so that we can detect anomalies. So that work led me to start thinking about multiple sensors. In the last 1 year, I started looking into IoT. So our interest mainly was in trying to figure out the hardware. And the particular hardware we built right now is 1 inch by 1 inch, and it can communicate through wireless through over about half a kilometer to 3/4 of a kilometer. So you can put something this on the device, then I can talk to another device within about half a kilometer to almost 3/4. The other important thing there is it will be sleeping, so you can wake it up and then interrogate and then get responses. That is, we are trying to commercialize that, so I'm not going to talk about how the circuit looks. So that is the today morning at 4 o'clock I was trying to figure out what can I tell about this, and there's a beautiful website, Jeff Barr. He explains this whole IoT pretty well from Amazon.com. So what is so special about IoT or Internet of Things is here. So you have, this is almost like a computer for you. So the little chip, earlier people used to say, okay, I'm going to put a computer on the chip. But here you have computer on the chip, but this chip can talk to another chip. So you can build a whole network of things using it. So one is the mass-produced compute power. Second idea is connectivity. Third idea is the big data. These are the three important driving factors. So you can have power on this little chip, and it's going to be fairly less consumption of power, the second idea. And then almost all embedded devices can have this the particular IoT. The widespread, widespread connectivity is the second one. Either wired or wireless, both of them are possible. And the processors talk to each other. That's why the distance becomes important. And also because it is wireless based, it can go through any kind of medium. So there won't be a lot of intersection of signals. And it is not ubiquitous, it is not available all the time, but you have to wake it up. That is the third point. Big data, obviously, you have so many of these little things hanging around. They are all collecting data. For each one of these IoTs, I can connect almost 64 sensors. So I can have this 1 inch by 1 inch device, or I'm sorry, 1 inch by 1 inch circuit, into which I can connect 64 sensors. Imagine 64 sensors collecting data all the time. So this is from NIST. They said by 2020, so many 4 billion people and 31 billion devices will be connected. This is an estimate. So like any other estimates, like Watson said, the whole world will need 5 computers. So but now it is different. So what is going to happen? Everything is going to be connected. I gave a little demo in ISCRC panel wherein we were controlling a coffee pot and also a light using our internet IoT device. So essentially, we are going to, in the future, you can see, when all of us have smartphones. So as long as you have a smartphone, you can be connected to the internet, and therefore you are a thing in the internet. So I could almost technically call each one of us an IoT, because you have the smartphone, I can generate. If you enable GPS, then obviously it can see where all you are going, and I can find patterns of your movements. So this is the work as we are going to see, and all these companies are racing to do. And in fact, Amazon.com released a little button very recently, as of October 8th or 9th, something like that. And what is the problem? Cost. Okay, if you want to have a internet-enabled coffee pot, I don't know. Don't ask me why do you want all this, why do you want to move a chair. Don't ask those questions, but let's assume that we do these things. You are going to have, cost is higher. Okay. So, if anybody can make an IoT which is cost effective, I think we did it, so let's see what happens. What are the questions? When you talk of IoT and then the next level is smart IoT, you have intelligent manufacturing system, flexible manufacturing system, computer integrated manufacturing system, intelligent manufacturing system, and lights out factory. Now you have brilliant factory, right? That is GE's concern. So now I have smart IoT. The questions here are interoperability of data and protocol. How are you going to do that? That is the first speaker talked about, okay, I want some standards and protocols so that these boxes can talk to each other. And data interoperability and semantic interoperability. That is a problem all the time. So one particular device can send you the data on ports. Somebody else may be analyzing the ports. So they should be able to talk to each other, which means not only that you get the signal, but also being able to interpret, which would mean there must be semantic interoperability. So applications, I don't need to go here. This is give credit to. This is a beautiful paper. The Gubi et al. Future Generation Computing or of Computer Systems in 2013. You can Google it to see the various applications, and there's a good, nice table. What are some of the interesting aspects? People talked about these things, and I'm looking at my perspective. I talked about the higher point of view of IoT, but now let me go from my viewpoint. Sensing is important, number one, and then web services. So service composition, when you have web services, you need to compose them together, and then obviously with data analytics, I talk only about graph analytics because that's what I know most, or at least I think I know most, and then visualization and cloud computing. So you want lots of sensors. This is from the Japanese lab, I think, that is got cut off here. So you have sensors to sense much more. Okay, we may need that particular paradigm shift because of IoT, and research is needed in this. Is number one. And then web services. What is a web service? Okay. So when you go to Expedia, Expedia is a web service. What do you do in Expedia? 10 years back, in Expedia you could only book your ticket. You go and then you want to go from point A to point B. It will give you possible fares and you pick one. But now you can book your ticket. It will ask you for hotel, whether you want to book a hotel, and then it will ask whether you need a taxi or you need a car rental. All these things are combined together. Assume that each one is a service. They are enabled in the web, therefore it is a web service. To each one of these physical things, you are going to put an IoT device, which means all the web services are going to be IoT services. So this is what Amazon.com is trying to do at this point in time. And so earlier versions use SOAP, service-oriented architecture, and then you have this discovery mechanisms, and then people in the 1990 to 2000, not even 1990, but 2000 to 2010-9, the service-oriented architecture was extremely popular. This is a part of the SOA. And if you look at IoT, these are all different things. And each section of the IoT may be doing something. Let's say that is a service. You want to invoke this service unit. You want air ticket, you want a taxi, you want a hotel. You want to combine these things together. That is service composition. So we have a couple of papers. One is here in Service Science in 2011 informs how do you optimally combine these services together. So that's going to be a very important question. When I read Amazon.com's this log, what is that? A blog, I'm sorry, blog yesterday and today in the morning, I was happy that this kind of work we had been doing in the past. And there's two papers actually. This is one, and when you compose these services, you have to worry about the quality of service and also reliability. How reliable are these things together? Even when you are moving the physical internet, boxes are talking to each other, and when they're going onto your truck, you want to find out what is the quality of service of this particular truck, of the fleet of trucks, and reliability. Both of these things, here most people who are associated with QSR will be able to do them. These are the research issues in this. And there's another paper in IEEE. This is the IEEE Transactional Service Science in 2008. We talked about the semantic interoperability question. The other one is the analytics part. In the analytics part, when you have so many devices, so many IoTs connected together, you can't analyze this whole network. Professor Benoit showed you this video of the network. You can't analyze every node. It is going to become difficult. Can I cluster them? Cluster them based upon some similarity. The similarity can be connectivity in this particular case. Purely use that connectivity to do clustering on this. When you have billions of nodes, clustering is, it's an NP-hard problem. Therefore, you need to have fast solutions. From the research point of view, this is, I think this is a sales pitch. We developed an algorithm called label propagation algorithm, which is capable of even clustering nodes of this order of, clustering networks of the order of 500 million nodes in near linear time. Linear time in terms of the number of edges. So this is, in fact, this is a part of a lot of software like iGraph or RStudio, Python. All these things have the label propagation algorithm to do clustering. In this, you need a lot of research. Network science people have done a lot of research in this particular area, and our algorithm is second to another algorithm, which is the Lowen's method. Lowen's method is complex to implement, whereas ours is easy. It has its own drawbacks, but overall it's getting a lot of popularity. Other thing is visualization. How do you do visualization? Because they're all connected devices, I can think about how things are going to be moving further. This is more in the text domain. So one of my students, Seifu, is here. He did this particular work. If two chemicals co-occur in a paper, you try to, let's say chemical 1 and chemical 2, they occur in the same paper, then you try to put a link between them. So this particular graph showing that over a period of time, what we have done is we have analyzed about 700,000 articles from PubMed, open access, central open access site. Downloaded all of them and then used cluster computing to find out all the chemicals that occurred, and then visualized all of this to see what are the chemicals that are progressing over a period of time. Maybe one particular drug was useful in treating cancer on day one, but maybe today, after, let's say it was very popular in 1990, but today it is not popular, something else has come up. Purely by reading the literature, We do that so that anybody who's doing that research in that, they're able to see how things have progressed. Here we found an interesting observation through graph analytics and visualization that honeybees affect your diabetes. So that paper is okay. Don't worry about that paper. And the last problem here is all these things. Amazon does this now. This is from Ramesh and from UC Irvine or Davis. All these things are connected, but all the data is going to go to the cloud. So everything you do in the physical world, you need to build a cloud simulation, and all the services are going to be in the cloud. Service composition will take place in the cloud. So the thing, in fact, for a friend of mine, Sanjay Sharma from MIT, he talks about you are driving your physical car. In the physical car, you have IoT things, and from there the information is sent to a cloud. In the cloud, you build a virtual car. So the virtual car and the physical car, they talk to each other in real time. So then you can imagine if you are creating such a thing, where your trucks are, where your boxes are, where your people are. You can do so much of analysis. In that analysis, I'm a big proponent that graph analytics is possibly one of the main ways you can do it. So lastly, this is a book which I'm writing with one of my, I would say, former student. He graduated 2 months back, so that possibly when we write a book, maybe we understand it better. Thank you so much.
So now let's welcome our panelists to say the prompt so we can ask questions. Any questions?
Yeah, so we talked about the benefits of IoT, but there are some examples where there will be high cost. Like for once you said about the chips and the 2 connected chips or more than 2 connected chips, what if one of them went out of, what if one of them failed? What will happen? Would the whole system fail upon 1 failure or 2 failures? How reliable is that system? So, yeah.
Okay. Like in any system, when a component fails, right? Your question is valid.
What will happen to the overall?
Yeah, it is not necessary that the whole network is going to be brought down.
Uh-huh.
Okay. So when you talk of any large network, if you are going to analyze purely based upon the topology, topology is a structure, then intuitively you can feel that if you have some nodes, some of these devices which are highly connected,
yes,
versus some which are not that highly connected, which would mean that the degree of some particular nodes is very high compared to the other ones. Maybe you are connected to 100 people and somebody else.
So what happens if I fail?
So if that fails, then all bets are off. If your system is scale-free, your network is scale-free, and then if it exhibits, if somebody finds out this is the vulnerable point and kills it, the connectivity is going to be lost. Then if that is the case, then you try to build some remedies.
Okay.
So it is not that it is a lost cause, but still you can build remedies.
We experienced that problem last week in the construction project. Some of the facade, the tags didn't work. Then that affects the whole system. Then we had to figure out how to make the system robust enough. Okay, and we had another problem 5 years ago. We integrated all the systems like construction, manufacturing, all the workstations related to each other. And we had one workstation broke down or had some problem, some objects mismatching. Then that affects the next workstation. And we had to separate or make them modular. That was okay, we solved that problem. We are solving that problem.
Another aspect that we've been working on is thinking of them as individual objects with single sensors. For example, if you've got many containers that have sensors, if they have smart sensors that can locate not just their actual position, but other stuff, then you can have a social network of objects, okay, that is being captured and exploited. So you can validate. So for example, one is showing that temperature is too high. Okay? Is it just that its internal sensor is broken, or is there really an issue? So if you think only this one, then it's hard to know. But if you've got the other ones that are helping sense this, and none of them see any impact, and they are their neighbors, then you think, well, it might be a failure. But if the other ones begin to tell that this is the same issue, then we know there's really something. So this notion of if one fails, we're losing everything is not that dramatic. If we design it correctly. Okay? So if we design
it will be costly to design it in such a way somehow.
Yeah, clearly, but the view is not to design that for every single application. It's to develop the concept, the protocol, the principle, and that's how you design it. And then once you put that in perspective, then there's a lot of cost to get to that, but after that it's free. It's like in operation research. We spend years to develop an algorithm, but then once we've got it, we can solve problems very fast. But at one point, there's somebody who's got to sit down and think about it.
Solution, some solution. For example, like this session. If I am absent in the session, Kaibo has to manage this session. So it's exactly like this. So our system
it will not be as good. It will not be as good.
But inform goes next year somewhere. Okay, as popular as ever.
I think 15 years back, you use a computer. If the computer crashed and died, you lose it. That happens occasionally now also. But now you have recovery mechanisms, right?
True.
Yeah. So one question is the device failing, that if it gets killed, that part after a while it comes back to life. When it comes back to life, the fundamental question there is the state. Which state are you going to be back in? So, because we faced this problem 10 years back, there was part of the DARPA logistics program, where the question was, okay, this whole thing failed, this computer system failed. That can be a truck, or that can be a box, or whatever it is. And how do I come back to life, number one? Number two, which state do I go back?
I also have one more question with that.
Yeah, maybe after give others opportunity to move back to you.
I have a very general question. Is there any public available data to do this IoT kind of research? So I think it's kind of everybody has a specific type of data. You have some access to it. Is any public available data? No.
There are some that are available. Okay, like there's a poster just there. Okay, where they use data from NASA. That is completely available. Where they track the engines, and put sensors on it, etc. So that's there. And there's a number of sources. There are many people capturing data now. So depending on the field and depending on the relationship, they might not be completely public, but they're existing.
Yeah, I can share one data set with you
Yeah,
about the NASA's engine
I
data.
was about to point to the NASA data, and then there's a famous data set of taxi drivers. Yeah, I think Beijing, right? The big Chinese.
Oh, that's when Microsoft in China, right? Beijing, that's
Correct.
Okay.
Yeah.
That is only the mobile phone. That's the GPS.
But it's IoT, right? And likewise, there's data in the US based on FOIA from Google, right? Not from Google. Likewise, I think taxi drivers. I forgot the city. New York City, actually. New York City has there's public taxi data based on somebody filed a FOIA request.
Right. I
They will
don't
eventually grant
have
you.
a lot of public data to buy the rental.
Bicycles.
Data, right, absolutely.
Don't trust public data.
No data can be trusted, right?
Not really. IoT data can be really trusted because everything is tracked, traced, timestamped, responsibility start. So you cannot fit it.
In fact, there is a big data set at MIT, social networks group. Nathan, he has the whole Kenya cell phone data. From MIT Social Networks Lab.
MIT.
Yeah. His first name is Nathan. So he has it.
Can I answer differently to your question? Okay. To me, your question is dangerous. Okay, and they only want to talk with companies, and even they don't want to talk with companies. They just want a database. Okay, and then they're going to work with it. I think there's so many people, companies, and organizations that want to do good stuff with IoT, Internet, and the Internet of Things data. But if you, not personally, but everybody, if you're serious about getting there, get in contact with real ones, talk with them, find out their issues, okay? And as you'll build a relationship with them, they'll share more data than you can even dream of. But your research will be anchored in something that's going to have high relevance, instead of being stuck with data that has been captured for some other purposes in some other years, and etc. So I think the investment to get in contact with the real ones that have the issues in that data is worth it.
Yeah, I agree. You need the domain knowledge is really important when you do any extent of the data.
Yes.
I agree with it. So I completely agree, because the caveat there is if you want to start something tomorrow versus a year from now.
Or if you want to start tomorrow, find in your university, in your region, people that have begun there and team up with them to get a jump start. Okay, but don't try just to get some data somewhere and say, okay, I'm working in Internet of Things data. I really don't believe it. Okay?
No, I agree to this one, because almost 1.5 years back, a healthcare system came to me, and then they said, well, let's start working together. And now we have access to 64 clinics and 2 million patient data for the last 15 or 16 years.
But I think a lot of the industries, their data is kind of a limitation for publication, right?
In this case, not necessarily. Actually, we had a paper accepted for medical care with real data.
But what will happen, okay, is they will have you sign a non-disclosure agreement. That's clear, a confidentiality agreement that will say, don't share my data with anybody else without letting me know, okay? But then when you write a paper, you've aggregated so much information, you've put vanilla everywhere, okay, that nobody can really get back to the real data. If you're smart, and then you make your paper prove that you're not showing something confidential from your partners, and it will be okay. They're not there to stop you, but they're just there to protect, okay, because there's some issues that, for example, if they've got your name and how much you spend on all kind of stuff, okay, you'd not like that to become in my files, for example. Okay, so that's the issue.
Okay. Any other questions? Go ahead.
So I have a quick question. Although I'm not a student, so I don't know if I qualify for the question. But I was just curious. Coming from IBM research, I'm particularly interested in sort of eliciting comments from the panel about what kind of efficiencies you see for the B2B or the manufacturing and industrial settings by looking at sort of this larger set of data that IoT might enable.
What do you mean by efficiency?
So I guess there's a lot of discussion about how, especially I think Diego, you referred to it in your talk, that in a manufacturing setting, having IoT data being available from across the entire, say, manufacturing chain might help productivity and yield, right, in a manufacturing setting. So I'm sort of curious to understand, if there are any sort of thoughts and comments and examples of how that would happen. Right? I mean, one obvious thing we can think of is you can do system level sort of analysis rather than sort of asset level analysis. But I'm just sort of curious to elicit more sort of thoughts about it.
Can I give you an example that's not really manufacturing, but I think will get to your point? We did a study several years ago on when RFID came in, and my question was, what if I put an active RFID tag on every object and every card in a supermarket? What am I gaining? Okay, so imagine that now. Okay, every can, every box, everything, I've got a tag on it. Okay, question is, what am I gaining? And honestly, if you're not smart, the answer is nothing. But if you're smart and understand what you really have as differential in information, then you can gain a lot. But some things, for example, operationally, is the person got in the door. Okay? You have maybe their spending habits, what they buy normally in the supermarket. You can check live, okay, if you've got the stuff that the person has. If you don't have it, then you've got like 10 minutes until it gets to a given point, okay, where normally the stuff is. You've got that 10 minutes to be able to do something. Okay? If you're able to do something smart and have somebody come in and say, oh, mister, okay, your normal coffee that you love, okay, we don't have it today, but we're offering you to taste this one, okay, with a rebate because we feel that you'll discover something nice, then, okay, this is lucrative, okay? But if you're not able to gain from such things, then you get nothing. So it's basically what you do with the data and the analysis that you get, that's where the big payoff is. Operationally and as same as tactical, etc. So the answer to your question is, as a lot, if I put back in manufacturing, in predictive maintenance, or whatever, it has to do just getting the information, nothing. Analytics, get me the analysis, again, okay, it has to be well-aligned, smart, and if it's well-aligned, then I can begin to feed the decision, and it's the decision-making that makes the difference. You get me in this?
Sure, sure.
So this is like it's a three-level road to gains, and there the gains can be very significant. But again, okay, don't daydream. Okay, it's clear. Okay, there's work to be done.
Yeah, I guess partly I'm wondering if there are any sort of canonical problems that have emerged from sort of this, availability of data, right? That we don't look at normally.
Okay.
I can try to answer that question. Around between 2001 and 2003, we did some work with General Motors. This may not be IoT, but I'm trying to attempt to answer your question. So in the morning, a truck will come, or a set of trucks will come to the yard of GM factory in Flint, Michigan. And then they try to load these trucks with cars to be sent to vehicle distribution centers. From there, they go to the dealers. So that was the whole thing. So one is the loading problem. Loading which car should go first and which car should go next, and all that stuff. So what they were facing, the truck will come in the morning, he's standing there, people are running around, or the guy with the manifesto is looking, okay, car number 22 has to be in bay number 36 and parking spot 45. Goes there, car is not there. So what they did was, they put RFID on cars, and then an RFID reader and locators. So our task was to see this, take this information, build the necessary infrastructure so that the truck driver gets the exact information. So that is a spanning tree problem. So when we did solve that, for that factory, over a 1 year time period, it was leading to savings of $2 million. So this was there between 2004, then 2007 market crashed and things happened, and I don't know exactly where it was. This is one problem which combined RFID, real-time location systems, which will be similar in this case, in IoT. The important thing is that the information is much more dynamic and much more continuous.
One use case that I like a lot, and I actually learned about it only 2 weeks ago, even though all of you sort of probably know that there's aircraft engine maintenance stuff, right? That maybe somebody is doing it, right? So, but you never know sort of how much, right? So, but I learned recently that one of the large U.S. carriers, so after every single flight on landing, so immediately after landing and getting to the gate, they actually process sensor readings from all sort of sensors that are on the aircraft. And then if the aircraft needs maintenance sort of ahead of the actual schedule, they actually immediately start looking at rerouting that aircraft so that it gets to the maintenance station as soon as possible. Right? So which means that sort of in the quote old world, when they were not analyzing the data upon every single landing, they were actually losing a lot of money because sort of the aircraft sort of, let's say, I don't know, maintenance station says in Tulsa, Oklahoma, right? And they follow the regular schedule by sending the aircraft to SFO and then sort of from SFO to Tulsa, right? So now they can already, in Chicago, for example, they can learn, all right, so well, we cannot send this aircraft to SFO, we have to send it to Tulsa sort of right away. Right? So this is, I don't have dollar figures as to how much the airline is actually saving, but I think it's a very good use case that that definitely sort of is happening.
Another example along that is I was in a major car assembly plant in the southeast this week, and the fact that they don't have the information live on where things are within the plant in their logistics center nearby, basically you can easily see that at least half the inventory that they keep of parts of assembly, etc., within the plants could be removed. Okay, so if they were able to exploit Internet of Things information to really figure out where is what within the plant correctly. They know it. They're not stupid. Okay, they're nice, and so they know it for many things, but there's a lot of other parts that they don't really know, and they have to cover to double handling, double storage, and a lot of buffers, etc., to cover this lack of information. So now, if you've got it live with the analytics to grab the red light and the yellow light, and even avoid them to become yellow, then you're reducing this a lot. So instead of having to expand the plant, now they can do much more with the assets they already have. So that's an example that was this week.
Just probably some experience we have. On average, all our industrial collaborators achieve 20 to 30% improvement in efficiency, in addition to any other benefits. So that's the data we obtain.
So 20 to 30% improvement in efficiency. Sorry, which industry?
Manufacturing industry, shop floor.
So can I put you on the spot? What was the ROI?
The investment is okay. I give you one example we did with the air conditioning manufacturer. The direct saving is the cost for printing, the paper printing. Every day they spend 3,000 Chinese yuan on printing papers for the order. Okay, job order. And now they don't need to do this printing, they just use the electronic version for operation. And that saving is 3,000 per day. And within 2 years, that direct saving will cover the investment discount they put in for that project. You can imagine, okay, what's the return on investment. The gain is the 30% in efficiency, and also avoid firefighting between different partners involved in the shop floor. Because every day, almost every day, they receive a phone call from production department for canceling the order, or changing the order, engineering changes. Okay, it was a mess before that, but after the technology is used, all parties can share the information, work more happily together. So that's indirect benefits. Okay, so that's the IoT and benefits?
So actually, I have questions. If no more questions.
So the IoT, I think, is closely related to the big data, so generate massive big data. But the data size, that is like years of problems already. Like in the past, we also have the big data. So in your mind, there are several like data mining, those type of algorithms developed, such as for predictive maintenance. There has already been a lot of research in this area. But since of IoT, do you think what is the new challenges in this area? Are the existing data mining algorithm can be directly applied, or we need some incremental just modification, or in your mind there must be some new fundamental like methodology involvements, innovations in this area?
So let me start. So I think sort of a lot of the existing techniques can actually be used, but it's about sort of starting simple and then making it more and more complicated, right? So if you look at, say you have a lot of sensors on an engine or whatever, if you look at every individual sensor separately, then yeah, the science and everything else done, right? I mean, does most of it, right? And let's say relatively easy, right? But now if you want to look at the interactions among all the sensors, right? So now you don't have just one time series, now you have 40, 50, 100 time series, highly correlated, potentially highly correlated. And now you throw on the top of this, sort of you throw the age of every single engine and when it was repaired last time, etc., right? So the kind of additional features into the mix, well, that's where it becomes much more challenging, right? So that's where sort of, I think especially when it comes to real-time scoring, etc., I think there's more work needs to be done in that regard.
Kind of a follow-on to your question. There's obviously going to be missed packets, all sorts of data loss, missing sensor readings. How do you guys see missing sensor readings, and how do you deal with that kind of stuff?
That's a very good question. I don't think I have an answer. Sort of, it's.
What is the question?
So when you have all these connected devices, obviously Wi-Fi packets get lost all the time. Your buffers overflow. You don't have enough log space to log everything, right? So you're going to have missing sensors, but you're going to have multiple sensors watching the same thing. How do you guys handle all that missing sensor data?
The previous question and this question I'll try to address individually. One is this question about dealing with time series analysis, multiple time series.
Yeah, my question is whether you think there is need fundamental new methodology involvement.
If you want to go back to nonlinear time series, many of them can be. So you need techniques that can be faster, speed, representation and speed for processing. So going to your question, suppose I'm able to do it on board the sensor. And I have multiple sensors and build redundancy. Possibly I can address with multiple sensors. That's where all the reliability kind of people should come in to say, okay, how many I would need so that I don't die. So I think the IoT device, they are getting powerful enough that we have enough computing power. In fact, the one we built, we can do the processing of 64 different kinds of sensors and then send only the end product.
You may have to because of bandwidth and battery constraints.
Yeah, you can drain more power. So if you're draining more power, then you want to build redundancy. If that increases cost, those are all different bag of tricks.
I think I will deal with that question first. Okay, in our design, we do not allow any missing data to take place in our design. That takes place, but we use that technology we call the gateway technology. Process all the data from the sensor first. If there's any missing, then it will be dealt with first before the data is sent to the ERP system. Okay. But in the current majority of the design, you connect the sensor readers to the ERP system. We consider that is not acceptable. What leads to the problem you asked. So we have a gateway technology to solve that problem. For the data mining, or data analytics aspect, this is headache we are having for the moment. And we try to use existing methods and they don't apply. The data from IoT system are very strange, sometimes the time series and relatively not comparable. For example, for one company, we have the data for 10 years, and the CEO came to see me, George, can you improve the efficiency by 10% more by using the data? Then we look at the data, and it's like a string, okay, 10 years, and we don't know what to do with it. Okay, use time series or use statistics. Okay, and what are we analyzing using that? We don't really know. And also the decision making. Is it a stochastic system or is it not? Because we know everything is going on, what has happened. Okay, so far at the point, but we don't know what's next. So we are struggling understanding the nature of the system.
So I would say, so in my experience of missing dirty data, etc., you have to take it case by case, right? So I actually mentioned to you, I have a sport location data, right, in games. And yeah, I mean, you have players on the field and the ball is essentially on the move, okay, doing an XY coordinate, right? Well, you have to somehow face it, right? And in the smartphone data, so the project, the healthcare project that I described, I was talking about, yeah, GPS data can be off, right? Gyroscope sort of can all of a sudden sort of point to whatever, right? You have to clean it, so you have to come up with strategies actually.
I was thinking Kalman filter for the GPS.
Okay, that works for GPS, right? Other stuff, so I mean, you have to devise your own algorithms to cope with that.
This is a universal problem, not necessarily to IoT.
The reason why I ask is because in other cases the sensors are like directly wired, but in this case they're like wireless and they're intermittent and all that kind of stuff. So they're likely to fail because they're embedded.
The failing of the data.
Correct. Yeah. Well, a failing of the Wi-Fi or a failing of the sensor or a failing of the node. So that's much more prevalent because of the way it's connected.
As long as you don't miss the business information, business logic, that's enough. Yeah, sensor information sometimes is trivial.
The context dependent, like in the medical healthcare data, this is not IoT, but regular data. We had people of 8 feet 2 inches, and then 7 feet 4 inches, and it's not common. So then business room has to really talk.
Let's take a very simple example, okay? I'm tracking something, okay, and then for 3 seconds, I've got no data. Okay? Is it troubling? In some cases it is, okay? In some other cases, it's no big deal. I'll have data in I found data back in 3 seconds. So you have to find out what's the best. But for me to answer your question is basically the new capabilities that we can reach, given that we now have more data available. And like, got a case in the retail industry where we've got 1,000 dealers and they're importing stuff from foreign countries and trying to sort all this fast. And they were trying to do some resupply in season. They're very fashion, the resupply in season. And they were trying to do it, but it was like 90% using their nose, okay? So some data very basic. Now we end up, we've got data on the inventory in every single store. We have the number of people that got in there. We even have the number of people who tried the stuff. They tried it, didn't like it, etc. So we end up with so much more data to try to come up with the same decision, which is what product should I resupply and when, okay? But instead of doing just like a time series analysis, very basic, now we get with a multifactorial type of context within the complex relationship, so it becomes much more predictive modeling. So that is what I see quite a lot happening, and for us it's been a completely change of way of dealing. So that, to me, that's been very important. The other thing also is that, for example, with boxes, okay, or pallets. Right now, pallet, most of them are not smart. Okay, you don't even have RFID tag. So put yourself a little bit further when now we've got a tag on each one, and put a little further when we've got a tag, but also local intelligence associated with it. So now it can get involved in the decision making. How do you exploit this? You've got a bunch of research challenges associated with this, okay, with billions of them all across the world. So I'm going from one location to another, consolidation, deconsolidation, all kind of stuff. So this distributed intelligence that is sensor-based offers a huge amount of research capability.
I think maybe we can take one more questions, and then some panelists can catch flies. Okay. Maybe I
have, yeah.
You want? Okay.
So I don't have any technical question, but my question is, it seems like IoT in the future will somehow contradict with privacy. Some people will have some privacy and they don't want to share data. So you cannot know who want to share and who don't want to share. And how can you, what do you think about this? So there are some privacy issues in the future, I see.
I think it will have to be dealt openly. Okay? For example, I think it's a shame of companies that take data from me, okay, without my approval, into a bunch of things that if I knew they would be doing with it, I would never buy it again from them. In some case, I would sue them. Okay, so this behavior, okay, normally, okay, we should find ways to get rid of. Okay, but then after that, there's a lot of stuff that it's not that much of an issue. Okay, and many people don't really mind because you give a bunch of information every single day about your life. Okay, and you're okay with it. So, and it's the same in B2B. And there are many things that are confidential, other stuff that is not that confidential, especially with their trading partners. So I think you have to make this compromise, but I think it has to be much more like what do I give an okay for? Okay? And at one point you may get even paid to share some information. Okay? So I think that our whole way of thinking about all this, okay, is going to be transformed in the next 10 years. So that's an open field, right?
Where I would like to see this going, and this is completely where I would like to see it, right? It's a completely open market. In the sense, if Google wants to track me, fine, but let Google pay me for using my
some
own
people
data,
will accept, some people no.
Actually.
We cannot assume something that, based on this, people will agree. Some people would like this fact that they get paid, but some people, no matter what, I don't want to share.
In that case,
sure, there's a sort of okay. You will not earn money, but also data will not be collected about you.
Yeah, but
regarding privacy issue, I think we are all kind of educated. We know what information we share has privacy. So a lot of customers they don't know actually. They give up the Google they geotag for the kids middle schooler. They don't know what give up the information actually. But this one is very free area of the privacy.
I've heard a very good talk actually at Strata from the Benoit guy. He did a very interesting example. The talk was about Nest and a lot of other things. Okay, but he bought a sensor that weighs the propane tank on his grill, right? Because he wanted to know how much propane is still in the tank, right? So just a simple weight-based sensor, right? So put a propane tank on it. So then for fun, he's a kind of computer geek, right? So for fun, he actually pinged the API of that sensor, right? Because it was sort of open. And he figured out that actually the longitude and latitudes of that sensor were actually emitted through the API, right? This was one of those things, when you buy sort of a propane tank sensor, why the hell does it need longitude and latitude, right? It needs to know, so where exactly is my backyard and where is the actual grill in my backyard.
So you can even go on and blow it up.
Yeah.
Our construction project, we spent 6 months negotiating the agreement on data sharing with all stakeholders. So eventually, all subcontractors, contractors signed an agreement with Hong Kong Housing Authority share all the data. If you are not willing to do it, you don't get the business. I think that's that. So it's contractually written. So we were very lucky to be supported by that group of stakeholders for this project.
Okay, I think we run out of time for today. But if you have more questions, probably let's hold our passion waiting for next year to see what's going on in our cities, and then we can have more discussions. Okay, thanks for coming.